Great. So now we have the axis part. Now axes are a little bit more interesting because right now we're already setting it up for being both joystick and mouse axis. And that's not really what we need. So what we want to do is that we are going to say goodbye to the concept of the axis name here, and instead we are going to have struct here, which will describe an actual axis. We're going to call it an axis as well. That's going to be mildly confusing, but that's the way it's going to have to be. And what we want to do is we want to have a standard vector of axis references. And then I am going to have a couple of static axis references here. So we can have, or a couple of static axes. One is going to be called mouse X. One is going to be called mouse Y, and so on and so forth. We're going to have joystick 0, 1, 2, 3, 4, just to have a couple. Probably going to generalize that a little bit so that we can pull an arbitrary joystick axis. Especially because we're later on going to have to put that into the input class so that when we rebind that you can pull any axis and it'll figure out what to generate for this. But this is just sort of what we want to be able to use as defaults. Which is probably a good reason why I don't want these to be references. Anyways, so rather than here where we're using exact names, what we're going to do is we're going to say input axis mouse Y and input axis joystick 1. And similarly for the yaw, we're going to use joystick axis 0 and mouse axis X. Now the reason for doing it this way is that I can then instead go in and say, okay, for this axis, it's going to have an index, which is the index of this axis. And then we're going to have an enumeration, which is the type of this axis. And for now, we have mouse and joystick. So for example, the mouse X is going to be mouse or axis mouse index 0. So it's of type mouse, index 0, Y is index 1, joystick index 0, and joystick index 1, 2, and 3. So 1, 2, and 3. Great. So that means we should be able to code up this stuff. So when we have an axis, this, we're going to ignore the name again. And what we're going to do is we're going to have the... I really want to call a lot of this stuff axis. We're going to have the controls set to the defaults. So just like down here where we have button names set up as keys, private, we want to do something similar here with the axis. These were the controls. There we go. Now, rather than the button down here, where we're just looking through for the actual, the keys, I guess, where we just want one of them to be set. Over here, we're just looking for one key to be set. For the axis, we want to take the one that's the largest set currently. So what we are going to do is, for our axis, we have a get function. We are going to start with a value set to 0. Now this is a little bit interesting if you're moving multiple controls at the same time. Could also go for the first one that's sort of non-zero, which would probably be the easiest. So what we're going to do is we are going to go for every single of for every control in our controls. We are going to see if this control type, in fact, we're going to switch on that because that way I get a lot better control of it. I'm going to switch on the type. Should this be an axis mouse? We're going to do one thing, and if nothing, then we just continue on to the next control if we don't know what this is. For now, we're going to add in joysticks later. So right now we have the problem that if we get our mouse motion, we get it in one go, both axes, and then we reset both axes, which is a little bit unfortunate. So what we'd like to do instead is we'd like to say float raw input get mouse motion, and then we'd like to have an index on this, so we just get the one of them. And then what we're going to do is we're going to have a return value where we're going to look at our mouse motion based on this index. Then we're going to reset that mouse motion to 0, and then we will return the value. So of course we need to declare that interface as well. So in addition to being able to get both of these, we also have one which takes an index. Because that way, when we ask for this mouse motion, we can grab the motion. So we're going to grab a float motion on this axis, which again will be raw input get instance get mouse motion, and we're going to look at the control index to get that index. And if the motion is not 0, then we're going to return that motion. And in case we get through all of this and nothing is non-zero, we're just going to return 0 as the current motion on the axis. Now this is probably going to be really, really crazy. Okay, so I can actually call that an axis. So this will be an axis definition instead. Try that again. Okay, so these are static const expressions. which, if I'm not mistaken, can be initialized in line. Yes, they can. Out of line definition of axis does not match any in, yeah, because this is not an axis, it's an axis definition. And so is this. And this, by the way, is a button name at current. So we've managed to build our target longshot. Let's see if this thing loads and does anything even remotely reasonable. In fact, it does, which is always a good thing. So we still have complete mouse control, but now using our new wonderful little input system, to which we're going to add joystick control now. So joystick control here is defined in the HTML5 under the Gamepad API, and it has the concept of getting connected and disconnected gamepads. And then there are lots, so you can get callbacks when gamepads get added and removed. You can get the current number of gamepads, and you can get the state of the current gamepad, which will describe what the current gamepad looks like, what buttons are pressed, what the axes are. So yeah. Lots of fun stuff. So this thing gives us an axis number of axes, or timestamp number of axes, number of buttons. Then you have the axis analog state of gamepad axis, analog state of gamepad buttons if you have analog buttons, and a digital state of the gamepad buttons. Then you have a connected, an index based with the gamepad, so you can track a specific index, and an ID for the brand or style of connected gamepad device, and a mapping, which I have no idea what it is. But we're mainly interested in the top part here. Now the thing is that we're querying buttons and axes one at a time. We probably don't want to call this this gamepad function every single time we're looking for a single button. We probably only want to do that once per tick if necessary. So we probably need to cache it, which means we also need to invalidate that cache whenever we tick. So we're going to add to our raw input a tick function so that we can invalidate stuff. And then we are going to have our wonderful main loop over here. After we've rendered and everything's set up, we are going to go for our raw input. Input, we're going to get, input, raw input, get instance, tick. So we don't have that implemented, no surprise there. So what we would like to do is we want to keep track of whether or not we have gamepads attached at all. And if we do, we want to start querying them. So what we want to do is we want to count, have a gamepad count, and then we need extra events. We need the, see where they are here, gamepad connected and gamepad disconnected. So we have these, so we have gamepad connected. And we want gamepad disconnected. And these are going to take Emscripten, let's see, Emscripten gamepad events. Gamepad event. Then we're going to wire those up. So when we start up our raw, where we're adding all of these callbacks already, we're going to go for the Emscripten script and set gamepad connected callback. So our user data, this is, yeah, of course, this doesn't reflect any element. So user data is just this. We want to use capture, and we're going to go for the gamepad connected event here. So what I was wondering about was these things all have a null pointer first, whereas this thing doesn't. That's because these all refer to a specific element, and we just want the default element, whereas this is global, so it doesn't need to have a reference to an element. So same thing, we look for the disconnected callback and send that to our disconnected event. Great. So what we're going to do is we're going to have the raw input gamepad connected event here. I'm going to just dump to our log for a moment. Gamepad connected count now, and then we're going to output. Just going to do the same here where we grab our own reference. Self gamepad count, standard endl, and then we're going to have a similar gamepad disconnected. Apparently CLine and I kind of disagree about indentation at this point. So we're going to say gamepad disconnected. So here we are going to say that self, actually rather than doing this, what we'd like to have instead of having a pure count is I need to store the indexes of all the attached gamepads. I want to do an unordered set of size C and call it gamepads connected. There we go. So this will be gamepads connected dot size, and same down here. And what this thing does is whenever we get this event, we go to self gamepads connected and we insert from the event the index of the gamepad that we've just gotten. On the other hand, when it gets disconnected, we erase it. One thing where control reaches the end of non-void function, still need to return this mTrue to indicate that we completed successfully and nothing more needs to happen. And we also need our raw input tick function implemented, which for now is just a no-op. So that should link. If we switch over and we run this. So right now we're not getting anything about a gamepad being connected, but if I start moving the controller, we actually get a gamepad connect. Yeah, right. No indentation at all and break lines at every possible position. Reckon that's a great idea. That's not going to be impossible to read in any way. So what we want to do is that we want to get this wonderful little event whenever, or rather not an event, we want to be able to pull gamepad data. And we probably want to do it for every gamepad. So what we are going to do here is that we are going to have an... Actually, we're going to do this a little bit differently. In that what we're going to do is we're going to be a little bit pessimistic, and we're going to, or optimistic, and say that the gamepad data will always be used. So we want to take our input system as some of the first stuff so that it gets up to date or gets updated. Because what we're going to do is that we are going to have this not be an unordered set, but we're going to map the index of the gamepad to the Emscripten gamepad event. Let's see if that is a pointer or some other nasty thing. Okay, so it needs an action. Great. Because then we can store it there. Because by doing this, what we can do, I need to import the unordered map. Going to fail a little bit now because we can't insert stuff right now. But over in our input here, we're not just going to insert this index, but we're actually also going to store the current state of it by copying this event that we've gotten into the unordered map. And then for every tick, what we're going to do is we are going to go through every single controller or gamepad. So for every gamepad in our map, so that's in our connected, gamepads connected. Gamepads connected. What we are going to do, so this is theory, I should be able to say say index state, if I remember this correctly. Seems to work. And then we are going to say Emscripten get gamepad status for this index stored back down into the state, and that should do it. And this is one of the wonderful syntaxes that C-Line doesn't understand yet, so it's going to be complaining about this being not a valid variable, but it is. So what we can do now is that we can go into our editor. We can ask for whether a button is pressed, and we can ask mouse motion. What we can also do is float get gamepad motion for some index. Or rather, we can say get gamepad axis. And what we can do to implement that is we can say raw input get gamepad axis. What we do is we run through every gamepad we have. Same idea as down here. And if we don't find anything, it's 0. But if the state dot, and this is wonderful because it can't complete because it doesn't understand this part. But we have our wonderful little gamepad stuff. We have an axis. If state dot axis for this index is okay, if the absolute value, because there's this concept called dead zones, which we might want to handle ourselves. Anyways, if the size, actually we can just quickly test that. So if we jump over here and we look at our gamepad tester, you'll see if, okay, so it's only updating occasionally, but you can see that the axes are never quite really 0, except in very extreme cases. So what we kind of want to do is we want to allow for a little bit of error, and it looks like something like 0.1 is sort of where we want to go based on my little motion of my controller here. Maybe 0.2. So if the size or the motion of this axis is actually, if that is greater than 0.2 floating point, we're going to consider it as being moved right now. And then we are going to return that state. So we're just going to grab the first gamepad that actually is being moved.